Here's what you'll do in this lesson and what you'll be able to do after this lesson. You'll be able to identify place value in decimals. A few examples of that are these right here: hundredths, tenths, and thousands. You will be able to convert between decimals, fractions, and percentages. And you'll be able to define recurring decimals and convert them back into fractions. Let us first start off by defining what a decimal is. A decimal is a fraction where the denominator is a power of 10. What do I mean by a power of 10? This is just 10 power 1, 10 power 2, 10 power 3, and so on. So if you have a fraction where the denominator is a power of 10, that is what we call a decimal. Another thing that is crucial in this topic is what place value is. Place value is quite literally what exactly it says. It's the value of the digit in a given place. Obviously, place as in the place in the number. I can explain that with an example. In the number 3.27, there are 3 places that are there. There is this right here, the second place, and the third place. These are just the values of those digits in that place. So the place right before the decimal point is known as the ones place or the unit place. The one right after the decimal point is known as the 10th place, and the one 2 spots after the decimal point is known as the 100th place. The 100th is just 1 over 100. The 10th is just 1 over 10. And the ones is just 1. So what this tells you about the number is that there are 3 ones, there are 2 tenths, and there are 7 hundredths, which gives you a good idea of what the visual representation of that number is. Therefore, in that example of the pizza, we have 3 full pizzas, which are represented by this number 3 here, which is in the ones place value. Then we have 2 tenths of a pizza, so that can come here, 2 tenths. And then we have 7 hundredths, so like smaller slices, 7 of them. And that's what this number describes visually. Next up, we'll look at the conversion between a decimal and a fraction. How do you get a decimal to become a fraction? For that, we use the smallest place value, meaning the place value on the far right, which in this case is the 100th in our example, and we use that smallest place value as our denominator. And we also remove the decimal point. So if you're told to convert 3.27 into a fraction, the way you do that is look at the smallest place value, which comes under this number, which is the hundredths, and that as 100 as your denominator. And so what we would do after removing the decimal point, it would become 327 over 100. And that is a conversion of that decimal number into a fraction, using place values to do that conversion. Percentages are another way of representing numbers, and it is usually shown by this sign right here. And its literal definition is per 100 or out of 100. So therefore, it is just a fraction with a denominator of 100. Now the conversions. If you have a fraction and want to convert it into a percentage, what you can do is first convert the fraction into a decimal, which is done by long division, and then convert the decimal into the percentage. Or your second option is to get the denominator of that fraction to 100. And once that happens, whatever the value of your numerator is the percentage. Then how do you actually convert your decimal into a percentage, which was required for that first way of converting a fraction to a percentage? What you do in this is quite simple. You just take your decimal and multiply by 100. And this just means that we want to shift our decimal point 2 places to the right. And if you want to go the other way around for either of them, you just do the opposite of these. So a percentage to a decimal, instead of multiplying by 100, you do the opposite, which is take the percentage and divide by 100. And that would then take you back to that decimal. Let us take an example, which is 9/20. We will convert this into a decimal and a fraction. To convert it into a decimal, what we have to do is long division. So we would divide 9 by 20. But remember, 9 is just 9.0000 and so on, right? You can add as much as zeros you want after the decimal point. And now we can do this division. So 20 goes into 9 0 times. Then in order to go to the next number, we would have to put our decimal. And now we have 90. 20 goes into 90 4 times. You can subtract 80 from that. And we get 10. Then we bring down the next 0. And 20 goes into 100 5 times. Then we can subtract by 100 and we end up with no remainder. Therefore, 9 divided by 20 is just 0.45 in decimals. And in order to take my decimal number and convert it into a percentage, what we would do is multiply by 100, which is just shifting the decimal point 2 places to the right. So I'll take that decimal point, 1 place to the right, 2 places to the right. Therefore, this multiplication right here will end up becoming 45. And then that is going to be our percentage. So that's the conversion between our fraction, our decimal, and our percentages. Finally, we talk about recurring decimals. What recurring decimals are is never-ending decimals, but there are types of never-ending decimals. Recurring decimals are a specific type of never-ending decimals that also pattern repeat. For example, 0.3333 and goes on forever. It's a never-ending decimal because it goes on forever, but it's also pattern repeating, meaning it has 3, one after the other. You can even have it with multiple numbers. So another example is 3.145, 145, 145, and so on. It's a never-ending decimal, and it's also pattern repeating. Those are what recurring decimals are. This specific type of recurring decimals, even though they never end, they can be written as a fraction. And another way of writing them is you add a dot on top of the pattern or the number that repeats. So for 0.33333, we would just write it as 0.3 with a dot on top, which shows that it's repeating. For 3.145, we would put 3.145 with a dot on each number. When we are talking about the conversion of that recurring to a fraction, there are a few steps to that. So step 1, we have to let x to become that recurring number. And then step 2, we multiply x by 10 power the number of digits that are repeating. So if you're looking at 0.3, there is only one digit that's repeating, which is 3. When you're looking at 3.145, there are 3 digits repeating. That is 1, 4, and 5. So dependent on that, you will multiply that x by 10 power 1 here or 10 power 3 here. We'll do an example after I explain the steps. Once that's done, step 3 is you subtract 1 from 2. And that subtraction also includes our x. So let's look at this with an example of 3.14 with 2 digits that are recurring. This just tells you that the number is 3.141414 forever. We'll start off by letting x equals to that recurring number. So x is equal to 3.14 recurring. Then we multiply that x by 10 power the number of digits that are recurring. Here there are 2 digits that are recurring. Therefore, I'll multiply x by 10 power 2. So x times 10 power 2 and 3.14 recurring times 10 power 2. 10 power 2 is just 100. So x times 100 will just become 100x. And 3.14 times 100, remember this right here is just 3.1414 and so on. If you're multiplying by 100, if you remember from the decimals to percentages conversion, you will move it 2 places to the right, which would make it 314.141414 and so on. Therefore, we just have 314.14 recurring. So 100x is equal to 314.14, where 1 and 4 are recurring. And then we will subtract 1 from 2. This is my 1. This is my 2. So I'll subtract x is equal to 3.14 recurring. What that will do is it will get rid of that recurring part, because you just have an infinite recurrence of 1, 4, and you're subtracting it by another infinite recurrence of 1, 4. So it would just go away. And then that 100x minus x is just 99x. And 314 minus 3 is just equal to 311. Then what you would do is, remember, we want to find what our x is really in fractional terms, because our x is what our recurring decimal is. Now we want that in terms of a fraction. So we will divide by 99 here, we'll divide by 99 here, and our fraction to represent 3.14 recurring is going to be 311 over 99.